Hello everyone. My name is Ravikant. I'm going to present my project titled Wildlife Species Classification using Deep Learning with EfficientNetv2-S. Let me begin with why this problem matters. Wildlife monitoring is crucial not just for conservation but also for ecological researches and biodiversity protection. Traditionally, identifying animals from images is done manually, but it is time consuming and error prone. So I wanted to explore how deep learning, especially image classification, help automate this process. That's where efficient V2S comes in. I chose this model because it's lightweight but also powerful model which balances accuracy and speed. For this project, I used Kaggle dataset containing images of 6 animal species lion, tiger, wolf, etc. Each image was pre-processed with 3 resolutions, as you can see. So I could analyze the effect of image size on performance. Overall, I had over 5,000 images, with 80% used for training and 20% of images used for validation. Hypothesis. Before training, I made a few key observations. First, I observed that 300 by 300 resolution images are performed best and they offer a balance between detail and competition. Second, I plan to use confidence threshold to reject unknown species animals. I also expected and observed that efficient at V2S to train faster and generalize better than like other traditional CNNs such as YOLO and ResNet methodology. So here's how I approached it. I used EfficientNet V2S trained from scratch. The model was trained for 15 epochs with a batch size of 32. I didn't use any pre-trained weights, and I also mentioned earlier I applied a threshold of 50% so that any prediction with less than 50% confidence will be labeled as unknown. Coming to literature review, I also reviewed prior studies like to back up my research. Um, as you can see, Gomez, Villa, and others show that higher resolution actually hurts performance of the model. Um, and Lopez and Singh, like for the second observation, um, it highlighted the importance of confidence thresholding, which I talked about earlier. It helps in real world classification. Coming to third observation, it demonstrated that efficient net V2 is faster compared to other models like YOLO and ResNet, as I said earlier. As training progressed, accuracy improved steadily, reaching about 64%, like around 64% on the training set, and around 52% on the validation. And training loss decreased consistently, showing the model was learning. But like I noticed some overfitting after epoch 14, which is not good. Classification report. The classification report revealed like interesting patterns of the model training. For example, cheetah 300 resolution had high precision and recall, but classes like tiger 512 or lion 512 had F1 scores of 0, which means like resolution really played a role in performance. Coming to confusion matrix, looking at the matrix here shows like we can see that some animals were often like confused with each other. For example, like lion and wolf are easily confused, likely because they are share similar like visual similarities. On the other hand, like we can see like cheetah 300 and hyena 512 um, were recognized more consistently. Now let's try out the model in real time. Let's go to Kaggle. I'll quickly go through the code once. Um, which I already did in previous demonstration. I imported Torch because like PyTorch is the framework I used to build this and train my model. Tim is a library full of like pre-built image models like EfficientNet and YOLO. Um, Next, um, this line of code like we are saving the best version of the model based on prediction and validation. Like after the confidence score, here we can see like every image was resized to 224 by 224. Um, Here I trained the model, and you can see loss and like training curves. The loss is going gradually decreasing, which is good after every epoch. For the accuracy, it is increasing rapidly, which is good sign for the model training because the higher it gets, the accuracy gets better. Let's test an image from Google randomly to see how our model works. Mm, let's take a cheetah. Okay, we can see already cheetah images here. Let's take a random one. This one looks alright. Copy the image. Open the pane to resize it. Save it as JPEG. Let's name it. New dataset, and we have to upload that file here. Yeah. Let's name the data steps. Create. It's created. It's created now. Let's take this path of this image and change it here. Let's run the code. We can see the output like with 99% confidence it says cheetah, which is absolutely right. So our model worked pretty well. Let's head on to our presentation again. So coming to discussion part, what did we learn from this? First, like 300 by 300 resolution balanced with clarity and computational sign. Second, using a confidence threshold made like the system more reliable. Third, like efficient net v2 is proved to be compact and fast for training, and it's also a lightweight model. However, there are some errors still occurred like due to pose variation, background lighting, and species similarities. It always happens. Coming to conclusion, in a This project showed like how deep learning can be applied effectively for wildlife classification using images. We found that like resolution matters, thresholding adds safety, which is a big thing for image classification, and efficient netv2 is like solid architecture for this task. Okay, in future we can expand like this project by adding object detection and test on real camera traps like in the field. It will help researchers and adds up to ecological conservation. Thank you. That's it from my side. Thank you for listening.